So for questions 1, 2, and 3, we're asked to solve each quadratic equation by factoring. When we factor, the first thing we want to make sure is that we have 0 on one side. So for question number 1, we do have 0 on one side. Then we want to check for a greatest common factor. So I'm looking at all three terms on the left, x squared minus 8x plus 12, to see if they have anything in common. In this case, they do not. So since it's, again, three terms, really the only way we know how to solve it is using our asterisks. We have an a value of 1, so 1 goes in the top left and top right because this number right here is 1. B goes to the bottom middle. B in this case is -8. So -8 goes to the bottom middle. For the top middle, we're going to multiply A times C. So 1 times 12 is just 12. Now I'm looking for two numbers to fill in my blanks that multiply to give me 12 and add to give me -8. -2 and -6 multiply to give me 12 and add to give me -8. Perfect. Then we're going to look at these fractions here on the sides to see if we can reduce. Neither one reduces, so we're going to add our x's to the top, and then we're going to shift them sideways to get our two factors, x minus 2 and x minus 6. Still equals 0. Then we're going to use what we call the zero product property. We have two sets of parentheses being multiplied together. Since their product is 0, we know that one of these factors, or both, has to equal 0. So we're going to set both of our factors equal to 0. So this is a little bit different than what you had to do on your first quiz, because now we're asked to solve. So once you factor, set both your parentheses equal to 0, and then get x by itself. So x equals 2, x equals 6. So we've got two answers for question number 1. Questions on this one? Okay. If I get to going too fast, holler at me and I'll slow down. Question number 2, again, we're asked to solve by factoring, but we do not have 0 on one side. So the first thing we want to do is move the 4x and the 7. So they're both negative, so we're going to add them both. When I add them, I add 1 on the left side of the equal sign and 1 on the right side of the equal sign. So now I have x squared plus x minus 30 equals 0. So now again, we have three terms set equal to 0. I'm looking for a greatest common factor, but again, there is not a greatest common factor. So I'm just going to fill out my asterisks. We have an a value of 1, a b value of 1. And then for the top middle, when I multiply 1 times -30, I get -30. I'm now looking for two numbers that multiply to give me -30, but add to give me +1. So we're going to use 6 times -5. 6 times -5 is -30, and 6 plus -5 is +1. So now we're looking at our two fractions to see if we can reduce. We again cannot. So we're going to add our x's to the top and then write our two factors. X plus 6 and x minus 5 still equals 0. Set both our factors equal to 0, so x plus 6 equals 0, x minus 5 equals 0. Gives us answers of -6 and +5. Questions on this one? All right. Moving to question number 3. When I look at question 3 again, we want 0 on one side, so we've got to move this 15. So we have 6x squared minus 13x minus 15 equals 0. Then I'm checking for a greatest common factor. Again, there is not one, so we're going to use our asterisk. We have 6 in the top left, top right, -13 in the bottom middle. Be very careful. When you fill in the top middle number, you want to multiply a times c. 6 times -15 is -90. So normally if people mess up question number 3, it's because they write -15 instead of multiplying it by the 6 to get -90. So then we're looking for two numbers that multiply to give us -90 and add to give us -13. Yep. So 5 and -18 multiply to give us -90 and add to give us -13. Again, for numbers like this, our factor sheet comes into play. It's very easy to find your factors for 90 if you have your factor sheet. This time I can reduce 6 and -18 are both divisible by 6, so I have 1 over -3. Remember that negative has to stay on the bottom. So add our x's to the top, and now we have factors x minus 3 and 6x plus 5. So when I set them both equal to 0, for the first one, I get x equals 3. For the second one, I kind of have 2 steps I need to work on. So first thing I would do is subtract 5s. That gives me, 6x equals -5. And then I would divide by 6 to get x equals -5 over 6. I would leave it as -5 over 6. Instead of typing it in my calculator to get a decimal, just leave it as your answer. Questions on this one? I'm gonna clear it and scroll up, because question number 4 is gonna use a little bit of room. So question number 4, again, we're given a quadratic, but this time my instructions say to solve using the quadratic formula. The quadratic formula is on your reference sheet, so you have it. But before you can use it, you want to get 0 on one side by adding 4x and adding 3. So when I do that, I get 3x squared plus 4x minus 4 equals 0. So now when we use our quadratic formula, we're going to use an a value of 3, a b value of 4, and a c value of -4. So quadratic formula, x equals, the first thing we want on the top is -b. That means the opposite of whatever b is. So currently b is +4, so the opposite of that would be -4. Plus or minus Then underneath my square root, I need b squared. So 4 squared minus 4 times a, which is 3, times c, which is -4. All divided by 2 times a, which is again 3. Keep in mind on your test, you get 1 point automatically for writing this down for me. For our second step, we want to figure out what the discriminant is, or the numbers underneath your square root. So just this highlighted portion is what you want to type in your calculator. Everything else will stay the same, except you can multiply the 2 times the 3 on the bottom if you want. So when I type that highlighted portion into my calculator, I got 64. You have to decide, is 64 a perfect square? Yes, 64 is a perfect square. So we're going to take the square root of 64, and what's it give us? The square root of 64 is 8. The square root symbol's gone. So really now we have 2 problems we need to solve. So since the square root's gone, we're going to have 2 answers that are numbers. Whoops. So for one of them, we're going to have -4 plus 8 divided by 6. For the other one, we're going to have -4 minus 8 divided by 6. So we're splitting up that plus or minus sign into 2 separate problems. So for the top one, -4 plus 8 is, 4. So 4/6, which reduces to 2/3. So there's one answer. For the second one, you have -4 minus 8, which is -12 divided by 6. Well, -12 divided by 6 reduces to just -2. So 2 answers, one of them is a fraction, that's okay. So 2/3 and -2 are your 2 answers. Questions on the front page? Okay. Moving to the back. So on the back page, we have the area of a rectangle is 135 feet squared. Find the dimensions of the rectangle if we know that one side is 12 feet longer than 3 times the other side. Oof. So 3 times the other side plus 12. And I'm just going to use W for the other side, the width. If I ask you to find the area of a rectangle, hopefully you know that the area is length times width to get your area. So we're going to take the W times the 3W plus 12. If you use X's instead of W's, that's fine. Equals the area, in this case, 135. So really, I'm asking you to solve this equation. The first thing you want to do is get rid of your parentheses. So we're going to distribute the W in. So 3W times W is 3W squared. And 12 times W is 12W. Still equals 135. Hopefully when you look at this, you notice that it's a quadratic. It's got an X squared, or in this case, W squared in it. So we want to move the 135 to the left side to get 3W squared plus 12W minus 135 equals 0. If I would go to put this into my asterisk, I would have a very large number in the top middle, which I don't want to do. So this does actually have a greatest common factor. You can factor out a 3 from all 3 terms, or all 4 terms if you want. So divide everything by 3 all the way across. So every single term gets divided by 3. Promise it's going to make your life easier. So if I take 3w squared divided by 3, I just end up with w squared. 12w divided by 3 is 4w. Negative 135 divided by 3 is negative 45. Equals, and then 0 divided by 3 is just 0. Now we have a much smaller equation, or number smaller in our equation, that we can use our asterisks on. So if I put this into my asterisks, I have 1 in the top left and top right, 4 in the bottom middle, and 1 times negative 45, which is negative 45 in the top middle. So now we're looking for two numbers that multiply to give us negative 45, but add to give us 4. Negative 5 times 9. So if I look at these two sides, neither one is going to reduce. So I'm just going to go back over here. My two factors are going to be w plus 9 and w minus 5. Zero product property tells us that since we have two sets of parentheses being multiplied together and their product is 0, then one of them must equal 0. So if I set w plus 9 equal to 0, I get that w equals negative 9, or w equals positive 5 when you set w minus 5 equal to 0. But remember, w represented the width up here of my rectangle. Do both of these answers make sense? If I ask you what the width of your table was, would you tell me the width was negative 9? No. So this answer, you didn't do anything wrong. It's extraneous. It's just an extra answer that does not make sense. So here we're going to use a width of 5. But we want to know the dimensions of the rectangle. So we know that the width is 5. But now we need to find the length. How do I find the length? Well, right here's the equation for the length, 3 times the width plus 12. So I'm going to take 3 times 5 plus 12 to figure out what the length is. So 3 times 5 is 15. 15 plus 12 is 27. Oh, that. So final answer, the width is 5 feet, the length is 27 feet. You don't have to write a complete sentence for it. Just label your answer when you get there. It's kind of a bunch of work in a little space. So the width was 5, the length was 27. Moving down to question number 6. So we're using this quadratic equation to answer parts A through C. So when I look at the equation we were given, it's already in standard form. I already said equal to 0, so we don't have to worry about that. The first thing we were asked to do for part A is find the value of the discriminant. Remember, in your quadratic formula is the formula to find the discriminant. So you have the quadratic formula on your reference sheet, but you've got to know that the number you get underneath your square root is the discriminant. So all we need to do for part A to find the discriminant is take b squared minus 4ac. The biggest mistake students make on this part is they don't use their parentheses. So b squared is negative 3 squared. You must put that into parentheses or you're going to get the wrong answer. Minus 4 times A, which is 3, times C, which is 6. A, B, C.
Is Alexis on the Zoom call? She's having a hard time getting in. I'll keep up with her. I sort of see she's trying.
So in your calculator, you can type this in just as it's written. Again, make sure it's in parentheses. Everything you plugged in goes in parentheses. So when I typed that in my calculator, I got an answer of negative 63. If you didn't get negative 63, I would double check that these parentheses were used in your calculator. All right, so based off that answer, we should be able to determine the number and type of solutions of this equation. Remember, if we get a positive number, we have 2 real solutions. If we get a negative number, we have 2 imaginary. And if we get 0, we have 1 real. So in this case, we got negative 63. Since negative 63 is negative, our answer is going to be 2 imaginary. Also want to point out that letter D, this one here, will never, ever, ever, ever happen. Imaginaries always come in pairs. So there's always going to be 2 of them, or 4 of them, or 6 of them. Always an even number. Questions on part A and part B? Okay. For letter C, we're going to use that same quadratic equation in our quadratic formula. So we had y. So we have this equation right here. When we're using our quadratic formula, again, this number is A, this number is B, and this number is C. I want negative B, so the opposite of negative 3 is positive 3, plus or minus. Underneath my square root, I want B squared, so negative 3 squared minus 4 times A, which is 3, times C, which is 6, all divided by 2 times A, so 2 times 3. So when I go to type this portion right here into my calculator, what do you get? You should get the same number you got for part A. Remember, the discriminant's exactly what's underneath your square root. So if they don't match, you did one of them wrong. So they should automatically match each other because they're the same thing. So now I want to go ahead and start simplifying. I'm going to check, is 63 a perfect square? No, so I'm going to have to take the square root of negative 63 and break it apart. So I want a perfect square times some other number that gives me 63. 7 times 9. So the square root of 7 times the square root of 9, since it's negative, I know I'm going to have an I out here too. I know the square root of 9 is 3, so I'm going to have 3i times the square root of 7. So I'm going to go back to my problem. I'm now going to have 3 plus or minus 3i times the square root of 7, because that's what the square root of negative 63 simplified to, all divided by 6. The last thing you have to do is check to see if this reduces. Does it reduce? Yes. So we're going to divide everything by 3. When we divide everything, remember, we're only allowed to divide these 3 numbers by 3, the 7's being protected by the square root. So now I have 1 plus or minus 1i square root of 7, all divided by 6. Final answer. Questions on this one? Oh, I should have reduced the 6. I messed up. I mean, I was checking to see if you were paying attention. Good job. Make sure you reduce all 3 of them, 1, 1, and 2. My bad. It's my first mistake of the day. Actually, my second, because I didn't get coffee this morning. Question number 7 is the easiest question on the test, if you ask me. If b squared minus 4ac, your discriminant, if your discriminant equals 0, tell me the type and number of solutions. What is it? It is D. If your discriminant equals 0, you will have one real solution. If your discriminant equals any positive number, you will have 2 real solutions. If your discriminant equals any negative number, you'll have 2 imaginary. 1 real and 1 imaginary is never, ever, 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 ever possible. If it equals what? If it equals a negative, it's 2 imaginary. If it equals any positive, it's going to be 2 real. And if it's 0, it's 1 real. So there's only 3 possibilities, and the 4th answer is bogus. Question number 8, we're going to use the graph we were given to answer all of these 6 parts. So first question says, what is the vertex? Remember, the vertex, if you're just given a graph, is either the top of the hill or the bottom of the valley. It's going to be the bottom of the valley right here. So you're just going to list this point as an ordered pair. That ordered pair would be -2, -2. Remember, start at the origin, you go however far left you need to go, and then however far down in this case. So -2, -2. Your axis of symmetry is always x equals, and then it's just the x coordinate of your vertex brought down, x equals -2. Part C says, what is the y-intercept? So here's my y-axis. I'm going to figure out where it crosses. Looks like right here to me. That is at 6. So you can either write 6, or if you want to write the ordered pair, 0, 6. That's okay. So one of those 2 answers will get you your point. Letter D, what are the x-intercepts? Notice the y-intercept was singular, and now we've moved to intercepts plural. So you should have 2 for your x-intercept. So x-axis runs horizontally. It's crossing right here and right here. So -1 and 3, -3. Or you could write the 2 ordered pairs, -1, 0, and -3, 0. So those are your 2 options. Make sure, for some reason in the past, I've had students write -1, -3. That is not correct. Because -1, -3 is this point down here. There's nothing going on down there. So don't write them together as an ordered pair. You have to separate them into 2 individuals, or just leave them as the 2 numbers. Letter E, what is the domain? I promise you, question number 8, letter E on your test is going to ask you what the domain is, and it's all real numbers. Or you could use the symbol for all real numbers, capital R with an extra line through it. The domain is like the x values that you're allowed to plug into the equation. You can plug in any x value you want. Because this arrow is continuing to the left forever, this arrow is going to continue to the right really slow. So every single parabola has a domain of all real numbers. Like I said, question 8, part E on your test is going to have an answer of all real numbers. Telling you an answer. What is the range? When you find your range, you have two options. You're either going to use y is greater than or equal to, or y is less than or equal to. To pick between these two, you have to decide if your parabola opens up or if it opens down. Which way does this parabola open? Up. Since it opens up, we want to use y is greater than, so we're going to use this first one. And then remember earlier we used this x coordinate of our vertex? Now we're going to use the y. All the way down here. Y is greater than or equal to -2. That's because the lowest y value possible on my graph is -2. So the vertex is the bottom point, it's the lowest point, has a y value of -2, so that's going to be your range. Questions on this one is worth 6 points on your test. Question number 9, probably my second favorite question on the test because it's also easy. No work required. Remember, this is in vertex form because we have these parentheses here. We want to take the opposite of the inside. The number on the outside stays the same, if I can spell. So I want the opposite of -5. So I want 5. And then the -1 at the end stays the same. So 5 -1 is my answer, which is letter D, worth 2 points on your test. Questions on this one? So remember, vertex form, opposite of whatever's inside your parentheses, number out at the end stays the same. It's actually written out on your formula sheet in the little box that talks about vertex form. Question number 10, answer parts A through C and graph the following quadratic equation. Part A says, does this parabola open up or open down? Remember, the number right after your equal sign, the A value tells you whether this opens up or down. Since it's negative, does it open up or open down?
Down.
Down. So since A is negative, it opens down. What is the vertex? Remember, to find your vertex, since this is in vertex form, we want the opposite and the same. -1 what? -1, +1. Your axis of symmetry is always going to be x equals, bring your x coordinate down, -1. So we've answered parts A through C. Now we need to graph the equation. So we know already our parabola should open down. It's going to look like a frowny face. Something like this. It should have a vertex at -1, 1. So I'm going to go to -1, 1, start at the origin, go left 1, up 1. So right here's my vertex. My axis of symmetry is going to go straight down through that. And then this is where we get to make a table. So we're going to make an XY table. When we pick X values, we want X values either right here to the left of our axis of symmetry or right here to the right. Anybody have a guess on which one I would use? I would use the two values to the right because they would be 0 and 1. So then in my calculator, I'm going all the way back up to the original, ignoring everything that I've already written on it. And we're going to plug in those values for X. plug in 0 for x, I get an answer of -1. That gives me this point right here. If I plug in a +1, I get -7, which gives me this point right here. So now my hard work's done. I just need to reflect these 2 points I just graphed, keeping the same height and same distance from the axis of symmetry. So this point right here is 1 unit to the right of the axis of symmetry. I'm keeping the same height, except I'm going 1 unit to the left. And I'm going to put my new point right here. I'm going to do the same thing with this point down here at the bottom. It's currently 2 units to the right. I'm going to move it 2 units to the left to get its reflected point. And then I'm just going to connect these to get my final graph. Oof, maybe. The graph doesn't have to be beautiful. Mine never is. Questions on this one? Question number 11. We're again answering parts A through C and graphing this quadratic equation. This time it's in standard form, not vertex form. So we've got to do a little bit more work. This question, I believe, is worth 7 points. The last one was worth 5. So it's worth a couple more points because you got to do more work. So does this parabola open up or open down? Again, the first number after the equal sign is A. That number will tell you whether it opens up or opens down. It does open down. So we know we're going to have a frowny face for our parabola. Notice I've switched the order. The last question asked for the vertex first and then the axis of symmetry. Now I'm asking for the axis of symmetry first. There's a reason. You have to find the axis of symmetry in order to find the vertex for this problem because it's in standard form.
Could you read those?
No. You could. But it would take you more time because it's not. It's not necessary. How's that? So for our axis of symmetry, since this is in standard form, we're going to use -b divided by 2a. That formula is on your reference sheet. So -b, I want the opposite of 12, which is -12, divided by 2 times a, which is negative. So really that's -12 divided by -4. -12 divided by -4 is +3. So my axis of symmetry is x equals 3. Now that we have our axis of symmetry, we're going to go back to the original equation, plug that x value in. So we're going to plug it in here and here to find the y coordinate of our vertex. So in my calculator, I would type -2 times 3 squared plus 12 times 3 minus 16. So I would type all that in my calculator. Careful with that negative out front. Make sure you use your parentheses as needed. So you should get a y value of 2. That tells us that the vertex is at the order pair 3, 2. So the x coordinate we got was 3. When we plugged that in, we got 2. So this right here is my vertex, 3, 2. So in my graph, I'm going to go to 3, 2. That's my vertex. Your axis of symmetry always runs straight down through that. So we're going to draw in our axis of symmetry. Remember, that's the line we always reflect over once we get our 2 points. So now I want to make my XY table. I want to either pick 2 numbers to the left of this axis of symmetry, so 1 and 2, or 2 numbers to the right, 4 and 5. Again, it doesn't matter. I always tend to pick the smaller, easier ones. So I would definitely plug in 1 or 2, or 1 and 2. And then since we've already typed all this in our calculator, we can just go back and edit, change the 3's to 1's. When I change the 3's to 1's, I get zeros. Go back, change the 1's to 2's, and you get -6. Oh, I wrote that backwards. I lied. -6 up here. Switch those. Should get 1 -6 and 2 0.
Oh, I thought you were Andrea.
I am Andrea.
Oh, you look so. You put that way too. You guys look so different.
No,
I found this. How are you?
I'm good. How are you?
I'm good. I'm just passing to say hi.
Hey. So we're reviewing for a test. We're gonna keep going. So we're gonna graph these 2 points, 0 or 6, 2 0, and 1 -6. And then we're going to reflect them. So this point is 1 to the left, so I'm gonna go 1 to the right. Then I'm going to go to the one at the bottom. It's currently 2 to the left, so I'm going to go 2 to the right. And then I'm going to connect my points. Questions on this one? All right. Question number 12, we have Jason who's jumping off a cliff into the ocean. His height as a function of time could be modeled by this equation here. H equals -16t squared plus 16t plus 672. T is the time in seconds and H is the height in feet. So part A wants to know Jason's height after 3 seconds. How would we find Jason's height after 3 seconds? So we're just doing a plug and chug. We want to find his height after 3 seconds, so we're going to plug the 3 into what variable, H or T? T. So H equals, and then I'm just going to have -16 times 3 squared plus 16 times 3 plus 672. So I would just type all of this in my calculator. Again, I can never stress enough, watch out for these negatives, don't leave them out. So Jason's height after 3 seconds would be 576 feet. Part B and C are kind of related to each other. So part B wants to know how long it took Jason to reach his maximum height. That's asking you for the x coordinate of your vertex or your axis of symmetry. So we're going to take -b divided by 2a. So currently the opposite of 16 is -16 divided by 2 times a, which is also -16. So we have negative 16 divided by negative 32. Do not make the same mistake some students have in the past. I've had students tell me that negative 16 divided by negative 32 is 2. It is not. 1/2. Since we're going to have to plug that back in, I would suggest you actually do this time convert that to a decimal, 0.5. So Jason reaches his max height in half of a second. To figure out Jason's maximum height, we're going to take that 0.5 and plug it back in for part C. So we're going to find his height at half of a second. So negative 16 times 0.5 squared plus 16 times 0.5 plus 672. So when we type that in our calculator, we should get 676 feet. So Jason's maximum height is 676 feet. Ready for part D? Part D says, after how many seconds did Jason hit the water? So when Jason's hitting the water, his actual height is going to be 0. So we're going to take and plug in 0 for Jason's height, and then everything else is going to stay the same. Negative 16t squared plus 16t plus 672. So that's step 1. When I look at these three numbers, first of all, I notice that they're even, so there is a greatest common factor. I'm going to cheat and tell you that you're going to divide everything by whatever number this is in front of t squared. So in this case, we're going to divide everything by negative 16. So all 4 terms get divided by negative 16 so that we can have easier numbers to use in our asterisks to factor. So 0 divided by negative 16 is still 0. Negative 16t squared divided by negative 16 is just t squared. Positive 16t divided by negative 16 is negative 1t or negative t. 672 divided by negative 16 is negative 42. So these numbers have all been reduced. Now we can go into our asterisks to figure out our factors. So we have 1, top left and top right, negative 1 in the bottom middle, and negative 42 in the top middle. So I'm looking for 2 numbers that multiply to give us negative 42 and add to give us negative 1. Those 2 numbers would be negative 7 and positive 6. So t minus 7 is a factor and t plus 6 is a factor. So when I set both of these equal to 0, I get t equals 7 and I get t equals negative 6. Now, since this is a word problem, I have to think back to what t represents. T represented time, right? So both of these would be seconds. Do both of these make sense? No, you would not tell me that Jason hits the water at -6 seconds. Jason would actually hit the water at 7 seconds because it makes sense in context of the problem. So 7 seconds is how long it takes from Jason jumping to Jason hitting the water. Questions or concerns on this one? All right, moving down to questions 13 through 15. So here we have addition, subtraction, and a multiplication problem with complex numbers. Remember, we're just going to treat the addition and subtraction like we would any other problem. Just combine your like terms. Question 13 has this little minus sign right here though, so we want to get rid of it, distribute it in. The first set of parentheses stays the same. The second set, the signs are just going to change. So now we have -7 minus 6i. And now we want to combine like terms. When I combine like terms, I'm going to take 13 minus 7 to get 6. -3i minus 3i is just same as -3x minus 6x. -3 and -6 combine to give you -9. The I just hangs out with it. So this is your final answer. Question 14 is easier this time because it has a plus sign. Since it's a plus sign, we don't have to distribute anything. We can really ignore the parentheses and just add our like terms together. So we're going to add 6 plus 8 to get 14. We're going to add 5i minus 7i to get -2i, and that's your final answer, 14 minus 2i. Question 15, however, does not have any symbol between the two sets of parentheses. Since there's no symbol, it's assumed to be multiplication. So we're going to multiply these two. I would say the best way to do it is just draw your box. 7 minus 2i goes on the side or the top. 3 minus 4i, again on the side or the top. And then we just want to multiply corresponding boxes. So if I'm looking at the top left box, I'm going to multiply 7 times 3 to get 21. Then I'm going to multiply 3 times -2i to get -6i. 7 times -4i to get -28i. And then be careful, remember this last box is the tricky one. -2 times -4 is +8. I times I is I squared. So being told that I squared equals -1, so really I'm taking 8 times -1, which means this box holds a value of -8. So remember I squared gets replaced with -1. That is on your reference sheet somewhere, the I squared equals -1, but you've got to remember to take it out, replace it with -1. So -1 times 8 gave us that -8. And then to get our final answer, we just want to combine like terms. So I'm going to combine these two terms. 21 minus 8 gives me 13. And then I'm going to combine these two terms. -6i and -28i combined to give me -34i. You should never give me an answer that has I squared in it. So 13 minus 34i would be my final answer. Questions on these? All right. Question 16 is very, 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 very similar to question 15. the first thing I would say to do, so we know this problem was solved incorrectly. We do not want to look at their work until we've solved it on our own. So sometimes I have students who look at the problem, try to figure out what's wrong with it, and then they work it out and do the exact same mistake. So don't look at their work. Go ahead, take the problem you were given and solve it. So we're going to box these two together. 5 plus 4i and 7 minus 2i. Then just fill out your corresponding boxes. So first box, 7 times 5 is 35. 7 times 4i is 28i. Negative 2i times 5 is negative 10i. And then your tricky box, we have negative 2i times 4i, which is negative 8i squared. Take that I squared out, replace it with negative 1. So really we have negative 8 times negative 1, which is positive 8. So to get our correct answer, we're going to combine like terms. I'm going to take 35 plus 8. 35 plus 8 is 43. And then negative 10i plus 28i is positive 18i, bless you. So I just went ahead and wrote that down there for the correct answer, 43 plus 18i. Now I can go back and look at their work to see what happened, where theirs looks different than mine. Which granted, theirs is written out sideways, yours is written in a box. But the first thing I look at, step number 1, we have 35, they have 35. We have negative 10i, they have negative 10i. We have 28i, they have 28i. We had negative 8i squared, and so do they. So their step 1 matches what I had first. Then they went to this next step. You can see that they just took these two terms and put them together to get the 18i. The 35 came down, then minus 8i squared came down. For the next step, 35 stayed the same, 18i stayed the same. But what happened here? So they took I squared out, but did they replace it with negative 1? No, they just dropped it. So they took the I squared out, but they didn't follow the instructions like we did to replace it with negative 1. So somewhere you're going to tell, or somewhere down here, you're going to tell me that in step 3, so step 3 is where they wrote something incorrect. So I would say step 3, they should have plus 8, not negative. You could, again, elaborate further because I squared equals negative 1. There's lots of different answers you could have here, but you need to have something about them not taking out I squared and replacing it with negative 1. Something about that I squared disappearing from the problem. They didn't change their sign. Questions on this one? Moving down to question 17, what is the conjugate of 8 plus 5i? Remember, to find the conjugate, all you are allowed to do is change the sign in the middle. So the 8 has to stay the same. The plus sign will just change to a minus. So the conjugate is 8 minus 5i, which is letter D. So question 17, to ask you about the conjugate, guess what you're going to have to use in question 18? The conjugate. So for question 18, we have to multiply the numerator and the denominator by the conjugate. Remember, the conjugate, when I give you the whole problem, comes from the denominator. So the conjugate of 8 plus 6i is going to be 8 minus 6i. D, yes. So we're going to essentially have two box problems, one for the multiplication of the numerator and one for the multiplication of the denominator. So we've got two problems kind of in one problem. So we're going to box the numerators together, then we're going to box the denominators together, and then just put our answers back together in a fraction.
I say 8 minus 6.
Yes. So the conjugate, we just changed the sign in the middle. So the original was 8 plus 6i, so we just changed it to 8 minus 6i for the conjugate. So my first box is going to be the numerator, 5 plus I times 8 minus 6i. My second box going to be the denominator, 8 plus 6i times 8 minus 6i. Then we're just going to multiply corresponding boxes. So 5 times 8 gives us 40. 8 times I is 8i. Negative 6i times 5 is negative 30i. And then for the tricky box, we have negative I times I, which is negative 6i squared. Take I squared out, replace it with negative 1. Negative 1 times negative 6 means that box has a value of positive 6. So in our answer, we can already have the numerator. So the numerator, if I combine like terms, I have 40 plus 6, which is 46. Negative 30i plus 8i is negative 22i. Then we're going to multiply our denominator. For our denominator, 8 times 8 is 64. 6i times 8 is 48i. 8 times negative 6i is negative 48i. And then our bottom tricky box, we're going to take 6i times negative 6i, which is negative 36i squared. Taking that I squared out, replacing it with negative 1. Negative 1 times negative 36 is positive 36. When I go to combine like terms from the denominator, I'm going to take 64 plus 36. 64 plus 36 is 100. When I go to combine my i's, I have 48i and negative 48i, which cancel each other out. So for my answer in the denominator, we're just going to have 100. But then when I look at my answer, I notice all three terms can be divided by 2. So we want to reduce this. So we're going to divide all three terms by 2 to get our final answer of 23 minus 11i divided by 50. There is another way that you could write your answer, and for your final, Ivy Tech wants you to write your answer this way, so I want to show you. I don't care, but on your Ivy Tech final, it does matter. So they just separate it into two terms, 23 divided by 50 minus 11i divided by 50. So they've just taken this fraction and broken it up into two smaller fractions. Again, that's an Ivy Tech thing, so I want you to see it before we get to that final. So either one of these answers will work for this test. I don't care which way you write it. Either answer is correct in my eyes. Questions on that one before we do the next one? Question 19, we're going to solve this system of equations algebraically. I've given you a quadratic equation and a linear equation, but notice they're both set equal to y. This is where we talked about if I'm the same age as Michelle, Michelle is the same age as, let's pick on Haley this time, Haley, then we can conclude that I'm the same age as Haley. We can just cut out Michelle in the middle. So really, we know that this box must equal this box since they both equal y. So we could have that x squared plus 5x plus 2 equals 3x plus 5. So first step, we're going to set these two equations equal to each other. Once you set them equal to each other, you want to move everything to one side. So I would move the 3x and the 5, move the 3x and the 5. So that gives me x squared plus 2x minus 3 equals 0. Now that we have a quadratic with 0 on one side, we can go ahead and use our asterisks to find our factors. So we have 1 in the top left, 1 in the top right, 2 in the bottom middle, -3 in the top middle, and then we're looking for two numbers that multiply to give us -3, but add to give 2. 3 and -1 is correct. Those two numbers multiply to give me -3 and add to give me 2. So then I'm going to look at my two fractions. Neither one reduces. So now I have factors. Well, I got to go up here. Of x plus 3 and x minus 1. Then I'm going to set them both equal to 0. So x plus 3 equals 0, x minus 1 equals 0. So that gives me two x values, one of them being -3, the other one being 1. Remember, when we get answers for these, they should be two ordered pairs. Our answer is going to be two ordered pairs. We just found the x values for both of them. So we know the x values of our answers, but now we have to find the y's. Two ways to find the y values. You can plug in 4x in the top equation, the quadratic one, or you can go with the easier route and plug it into the bottom. I would plug into the bottom equation. So for the bottom equation, if I plug in -3, I'm going to take -3 times 3, which is -9. -9 plus 5 is -4. So ordered pair -3, -4 would be a solution. Then I'm going to plug in 1. If I plug in 1 to the bottom equation, I would have 3 times 1 plus 5. 3 times 1 is 3. 3 plus 5 is... So I have two answers. Both of them are ordered pairs. Again, normally I have students who get to here to find the x values and then they forget to plug them back in to find the y's. So we're finding the points of intersection of these two lines if we were to graph them, which we don't even do. So -3, -4, and 1/8. Questions on this one? Then question number 20 is bonus on your test. So there's an option for you to earn, I believe, 5 extra credit points for solving that system. Everybody's going to do it, right? Hardly. Questions or concerns, anything you want to see again?